Okay, 3:20. So we're going to start. It's good. Okay. Thank you, folks, for coming today. We're going to talk about the performance analysis that we have done at Workday. Let me start introducing the company. Workday is a SaaS company, software as a service. We provide per subscriptions in the cloud, human resources and finance applications. We have extended our services to new products for our customers. Nowadays, we have over 1,500 customers all over the world. Introduction of myself, my name is Edgar. I'm a senior principal architect and Workday, part of the Workday Private Cloud. We all call it WPC. It's easy to stand for. It's part of an organization that is called the Platform Engineering Team. At Workday, I joined it 3.5 years ago, specifically to work on the private cloud project. Before that, I worked in different companies, Cisco, another SDN company, PlumGrid. I've been part of the community since 2011. The first summit that I attended was the Santa Clara back in that time. And played different roles in the community. I was part of the board of directors last year, and this year I'm the chair of the user committee. So I'm very, very involved in a lot of the activities around OpenStack. So today we're going to talk about what's the use case at Workday. Every private cloud or even the public cloud that they build, they have a specific use cases. At Workday, we have a very specific pipeline to put our applications into production, so we're going to describe that pipeline. We're now going to talk about an internal concept that we known as IMaaS as a service, IMaaS. Then we're going to talk about specifically the Glance and the Nova performance. Nova by itself, it's difficult to measure the performance because actually has calls to the other OpenStack components. If you put a VM, it's going to talk a Neutron project for creating ports, connecting those ports, attaching the ports, Glance image to retrieve the information of the image to be used in that VM. At the end of the conversation of the graphs that you're going to see, we're going to highlight some recommendations for the private clouds, and then hopefully we'll have enough time for questions. I have a lot of graphs in this presentation. I tried to reduce the amount of text that we're trying to bring to you. I would like to acknowledge that this work is actually part of the Workday team, a lot of collaboration with a specific team that we call internally SVT, System Validation and Testing. They help us to actually build this performance analysis. So what is the problem statement for Workday Private Cloud? We wanted to understand the limits of our private cloud. Why? We are very, very heavy on the control plane. Every Friday night, Workday updates the whole set of applications that we provide to our customers. If you think about Workday, it's not just one product that we provide. It's a set of different building blocks. Let's talk about 60 or 70 different building blocks that all together provide Workday as a product and also all the different modules, functionality, et cetera, that we have there. Therefore, we have to have a very stressed system on the control plane every Friday night because we killed all the old version of those services and recreated all over again. And as we keep adding more of those 60 different building blocks in this platform, the stress on the control plane keeps growing and growing and growing. So we're going to talk about scalability numbers in terms of how many compute nodes can your private cloud handle. That's a number that nobody knows. And nobody will tell you, yes, if you use this version on OpenStack, you will be able to handle 300, 500, 1,000 of compute nodes. That number doesn't exist. It's up to you. It's up the way you configure your private cloud. And that's actually the goal of this session, to explain what kind of configuration we did to actually tune the system to reach our SLAs with our customers. So we're going to talk about the number of compute nodes, the number of VMs that you can concurrently create and actually you can handle in the cluster, the number of images, and also network and policies. We want to focus a lot in the concurrency numbers because that's our use case, right? Other people, they may focus a lot in the data plane, specifically the telcos with NFS things. For us, that's not important because we have to have the VMs up and running in a very short period of time. The contract with our customers is 2 hours, the maintenance window, so we have to make it in that period of time. So let's talk about the private cloud use case. So first of all, we have our architecture. This is the basic reference architecture that you will find anywhere about OpenStack. So we have a box that is an OpenStack controller. One of the characteristics that our cloud has is we have a lot of security. We have all the communication is SSL based. So we have certificates for everything. We split the SDN part. Instead of using the vanilla Neutron with Linux Bridge or OBS, we're using OpenControl. And OpenControl has a set of components. We split it in two boxes, one that is the control controller, and the other one is the control analytics. Analytics is the part that actually has a copy of all the packages and the data play that is happening. And you can actually have very interesting information of the traffic that your VMs are doing. Yes, I noticed. I'm not sure what to do to stop that to happen. You should not do it in presentation mode, but I don't know. So I'm going to keep doing. The compute nodes, they host, obviously, the VMs. They have two main components, the Nova Compute, as everybody else, and the B router. In the part of the database, we actually have a replication of the database.
Do you want to change your energy saver settings?
Sure. OK, let's make a stop here.
Sorry.
No problem.
But it's going to keep happening, isn't it? System preferences. Energy saver. Are you in power or
battery?
15? Just wind it out. You're on battery?
Yes.
Okay. And you've got a screensaver working as well? Screensaver show with clock start after. Not going to happen, is it? Okay.
We shouldn't do it again. Let's give it a try.
And you're right, it was in presentation, right?
Hopefully it's not happening again. So in the database, we have a replication in a different server. That's just as a backup of all the data in our database. We also have certificates for the communication to the database. Basically, the rule that we have at Workday is every communication that leaves a box needs to be encrypted before reaching another endpoint. If the communication between the endpoints is in the same physical server, that's OK to not have it encrypted because it's secure in that box, right? And all these boxes are secured by IP tables configuration. So we protected at different levels of systems. OK, so we have a concept at Workday that we call zero to prod with images. What is this about? So first of all, you have the happy developers in the company coding in different programming language the Workday application, right? These 60 different building blocks. Once they completed a feature, a bug fix, a hot patch, whatever happens, they deliver this in two different form factors. Could be an RPM. It's important to mention that at Workday, we always deploy everything under CentOS. We have CentOS 6, 7, and 6.9 support, and also in CentOS 7.2 support. So this is why we always use RPMs and not Debian packages or something like that. We recently improved the system to actually deploy containers. So the developers could actually build their own container and give it to us as a container. So we have the two options. So that is fitted to an API, an internal project that we call IMAS, which stands again for Image as a Service. Basically, is an API that collects a CentOS-based image that is ready to be in production. What does that mean? Basically, it's a CentOS image that already have all the security hardening needed to be in production. We have a very high standards on security. We manage human resources information, payroll from the companies. So we have to have a lot of security requirements on those images. So these base images already have all those security requirements. It also has all the monitoring and logging needed for the application that is going to be running there to be reported to our centralized systems for both. We have a full visualization of what's going on with the application and also the reports in the logging part. So IMAS, which actually will publish that as an image into OpenStack, as a glance image in our OpenStack deployments. What is going to happen there will be a lot of testing of that image. There will be tenants which are just based on testing QA and SBT to validate that that image is ready to go to production. If that image is ready to go to production, they will update the metadata of the information, which is a Glance API, and it will tag it as a gold image. With that, it's going to start a cluster replication, which happens across all the data centers. So we have these clusters in all the data centers, and they do geo-replication across all of them. So by Friday night, all the clusters will already have in the Glance list this image that is going to be used to creating n number of images, n number of instances, for that specific application. And with that, on Friday night, we have a team that we call environments operation. You're going to start calling OpenStack APIs via another layer that we built. Sorry. We changed the configuration, but it's still doing it. It's going to create all the images that we will need to actually create Workday. Out of these 60 boxes, we are running in production 6 to 7 already, and we keep adding more and more applications. Our goal is to run as many as possible out of these 60 applications. Okay, so let's jump into the performance numbers. So just a quick summary. We support different applications, and we have a lot of these applications, they build different images, right? A feature could be built by different developers, so each one of them, they will publish an RPN, and it will create an image. So we have a lot of images created every day. And then we reached the last time that we checked over 2,000 images published in the last few months. We have in total 9,000 VMs in production, and we have around 1,000 VMs in one of the clusters, right? The 9,000 is in these 10 different clusters. We have 2 OpenStack clusters per data center. You think about it as like availability zones for Amazon, but in our premises. Okay, so this is the first graph. So what we're showing here is the number of images that is being added to the Glance server in a period of, I think this is 6 months. As you can see, we're still growing all these number of instances. We started with 1,000, we keep growing. We do some purchases of the images that we don't need it anymore, keep adding all these services, and we don't control these. This is a private cloud with some kind of public cloud use cases in the middle, because we don't control with the image system will start publishing, right? As you can see, this keeps happening, this is happening. And even that we purge images that are not being used, we can avoid that the system will keep adding and adding more images, because we have more and more services getting on board, and all of them, they publish more and more images. So that's the first use case that we need to cover, how we can actually guarantee that our system will not break with that large number of images. So let's talk about the Glance performance. So with the time, so what we're seeing here, the same period of time, another 6 months, you can see this is actually the percentage of the CPU consumed by the Glance API, and the blue one is the Glance registry. So as you can see, we start noticing that CPU consumption was growing, right? So we start getting worried here, which was reaching 20-25 of the CPU for the OpenStack controller. So one of the things that you need to have in your private clouds is this kind of visualization, right? If you don't have all these data to correlate what is going to happen in your clouds, you're never going to catch these kind of things, and this is going to keep growing, and it's going to crash your controller, and then you will have a big problem. So around this time, to start doing some testing what was happening, we have a team dedicated to, in a specific cluster that we call the perf cluster, just dedicated for performance testing, to start adding images and to break the system, and we start playing a little bit with the Glance configuration to find what will be the best stunning of our system. We actually make changes at the API level. At the beginning, we were using Glance directly with the event library, and then we switched to use Apache as a front end to actually improve a little bit the API performance. And then we changed the workers associated with this image. So this is the first report that I want to show today. All the graphs that you're going to see, most of them are either graphs created by our system that is called Waveform. that actually just reports metrics that either a NIOSH check or a sensor check is doing in the specific service. And the other ones, like these ones, is Rally reports. Rally, as you may know, is the performance testing project as a part of the OpenStack umbrella. So we're using we're using 1,000 images here, and we start calling the Glance List API, and we start doing it in different type of concurrency, right? And we start getting what was the average response time for that call. And you can clearly see that the average time is still growing as the number of images start growing in the system, right? So we validate what we were showing in our development clusters. And that's the moment that we start thinking what kind of changes we could apply to that specific configuration. You cannot go and test all these things directly on your development or production cluster, right? You have to reproduce the problem in a different cluster, and that's what we wanted to do in this one originally. So, and then we add different kind of parameters. We test the same glance image list API with some sequential calls versus concurrent calls. So we have actually a very large number of the images you can see here in the x-axis, and then in the y you have actually the time that it takes to respond. So you can see all the way when you reach these 12,000 and 50,000, the images you have up to 600 seconds, which is almost impossible to have an automation system waiting that long just to have a response of the API. So in the concurrency, if we change these to be requesting one by one, if we have a concurrency of 40, 80, 120, blah, 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 so we can also see that increases, but the time for the response is a little bit less drastic. What's the difference, right? Here you have one client and you have many, many clients calling it. Why we have it to test this? Because all the automation that we put around OpenStack in our premises, sometimes we couldn't control who will be calling an API for doing what, right? That's when I say that we have a weird kind of private cloud because we open some of the APIs for other teams. Why will another team will need it? Well, part of this IMAX process to tag image to be a goal one to go to production, they may retrieve some information for the rest of the images. Whether it was right or not, lack of some knowledge in the glance, actually they start pulling all these images. So with the monitorization that we put in place, we find out that they were doing this, and we can actually correct them, and we can actually tell them with a specific API they should be doing to not push so much into the system. Another test that we have is changing a different configuration of the workers, right? We have different sizes of the images, 500,000, 2,000, and then you can see different configuration to the workers, right? As you remember in the slides when I was showing the architecture, the Glance API was not living in their own box. If that was living in their own box, you can put all the resources for that specific API. But that will be ideal only if you associate one physical server for that service. In our case, that Glance lives with the Nova, with Keystone, and with the other components of OpenStack. So the resources, the physical resources of the server are shared. And we need to be careful that actually, just to improve one of the projects, you're not affecting the other one, right? So we're trying to find the best combination. I think the last one that we decided to do was around 16 workers for the APIs and the registry. We have 100% of success on this testing, and the response time was still in an average that we could negotiate in our SLA with the clients that we will call in this API. So what is the lessons learned here? Again, there is no fixed configuration that you can use. It's based on your use cases, based on the amount of APIs that you will be using. Maybe Glance, maybe there are private clouds that they just have 10 images, so this is worthless for them, but in our case was very important to get this. So once we have under control the Glance part, the images part, we start thinking about what's going to happen about the compute and network performance. Again, you cannot isolate the compute performance without testing the networking in a real scenario. Every time that you create a VM, there is a set of sequential calls for other components of the OpenStack, right? As I said before, the glance part, the networking part. Those are the essential ones. If you attach volumes, so you have connected volumes, that also Cinder will be involved. In our use case, we do not do that part. Everything is booted from an ephemeral disk, so we don't have into account the Cinder impact in this testing. Very similar to what we tested before. We have different numbers for the concurrency. We have 2 tests here, Nova Boot and Nova Show. One of the cool things with Rally is these tests are already there, but you can extend it as a plugins. And later I'm going to explain you that Nova Boot, it's not really the best Rally scenario that you want to test in your private cloud. The reason behind it is Nova Boot will actually wait that Nova changes the status of the VM from booting to active, and it will retrieve that information. What happened with that VM? They don't know. And many, many things could happen between the change of the state from the Nova point of view until the VM actually is accessible, and in the top of that, you have a service that you injected via cloud in it with some configuration to be running, as simple as a web server in port 4445. You have your web server that is running in that port. If for some reason it didn't start the service, you're expecting that service will be up and running, and you need to extend it. So that's what we did. Later, I'm going to show a graph that we call it Nova Working. So we create our own state. We call it Nova Working. We basically use the Nova Console API to retrieve the console of the VM as it is booting until we find a tag that we put it specifically in our base VMs. Basically, it says Workday image booted properly. So we're expecting for that tag, and then is when we say that the VM is in working state. A few things happen before that. The VM gets an IP address, so the HTTP is working. VM gets metadata information via the Nova metadata server, so that is working. And obviously, for those 2 things to work, there should be a routing configuration properly done in order for the VM has external access and inbound access. So that's what is important to extend it. And we actually have the code. Somebody asked me if we can actually publish that code. It will not help a lot to anyone because that tag is very specific to us. But we can actually come here and explain you how we did that plugin and explain people how they can actually do their own plugins if they're interested in doing it, right? So here, very clear. I'm not going to go for every single number. That's going to take me hours and hours. Let's go to the red numbers, the 95. So you start seeing 5% of the VMs are not getting into the booted state after you increase the concurrency to 80 VMs. So you just go there, say at the same time, a number of workers, give me 80 VMs, and we're still having some problems, right? So we know exactly at what rate of the VMs will start having a problem. So while you fix the problem, once you find out why you can only handle until 80 VMs concurrently, unless you can control your other orchestration system to say, okay, create VMs in bunks or 70 or 60 or 75. Wait for this period of time that they will be up and running in average. So we have the max timing for those ones is between 68 seconds. So wait for that, and then you start creating more VMs. This is the big difference between a successful scenario, which is in the top, and a failure scenario. Sometimes if your VMs, you handle it as cattle and not as a pets, you can actually push the system to this kind of behavior, right? If 5% of the VMs, they cannot come up, but that's not going to affect the functionality of the service, you may want to keep doing that thing, right? You may not want to change it. That is up to you and how you handle your use cases. But what is important to see is that the failure VMs are not the ones in the middle or at the end. They just randomly happen. You cannot control what is going to happen. So if you have different services, different tenants creating different VMs, you cannot predict which one is going to fail. It's extremely random. So we learned that from the system. But again, if you reduce the number of concurrency, you can actually have 100% of successful VMs booted and working. Today, earlier, there was a session with the public clouds, and I was talking to the public clouds guys. Hey, do you know exactly how many VMs concurrently your cloud, your public cloud, can actually create successfully? And it was a surprise that they didn't know. They really didn't know exactly what is the max number because in their scenarios, it's so randomly, right? There's not a specific period of time or a moment that all their customers want to start running VMs, like in our case. So as you can see, different scenarios, you will think that the public cloud, they will be very worried about it, but they're not. Obviously, talk to a couple of them, every public cloud will be different. Sure.
Once you have this kind of data, do you apply some rate limiting to the access of the control APIs? Or?
Yes, so I will go to that in the last slide. Then we changed a little bit the test, and what we do it is a very large number of VMs in this cluster. We even changed the configuration of the cluster, the overall allocation of the memory at the CPU to allocate these numbers. The cluster that we were using have 13 compute nodes. All of them, they were 40 cores with the overall allocation 80, half terabyte of memory. I think there were Dell servers. That we normally use Dell and HP. I don't think it's really, it's going to make a difference one vendor or the other in this specific configuration, right? But here you have a count of all the way to 1,000 VMs with different concurrency and the average time that you're getting. And again, right, when you have a mostly clean scenario, as you can see, everything is very successful. But when you start pushing too much into either concurrency, the number of failures goes all over the place, right? So you cannot guarantee that only the last ones are going to fail. It just happened all over the place. You cannot control it. That for us was surprise, right? Was a very interesting result. We were very happy to get it because then we can orchestrate a little bit more at the API layer what's going to happen for each one of these services. When we were reporting these numbers, I started getting curious. Actually, when I was putting these slides together, what will be the performance results reported by the community, right? So I went to the documentation in OpenStack.org, and I found these numbers, right? So somebody, but actually I don't know who did it, published this data. I put the link there if you're interested in finding this information. It's not associated to any release, so I will say it is one of the latest tests. I cannot guarantee which kind of framework they were using because I don't know, but I will try to find more information about it. But very similar tests, right? As you can see, they have here 176 compute nodes. They had 3 controllers, 1 Rally server. But what is interesting is they were able to run some number of successful of boot servers until suddenly start, drastically decreasing that rate, right? So this is 2 RPAs per second, as far as I remember from this testing, and these are the numbers. Now, the failure scenario you can configure by yourself, right? What fails for me could mean different for other clouds, right? Maybe in the public cloud, it is fine to get an API call, give me this VM with this flavor, and it is fine that the customer will be waiting, in this case, I don't know, 50 seconds, 2 minutes, and then it will be back saying, here's your IP address you can access, right? You're not so anxious. Actually, if you go to any of the public cloud providers and you create VMs, you're not like SSH right away, and you're just crazy and expecting to have the connectivity to the VM. You actually create VMs, do something, and come back and start working with those VMs. But again, in our case, we cannot do that, right? We actually have to have all that number of VMs up and running. One of the simplest applications that we run on OpenStack in our private cloud is our UI, the Workday UI. And we have over thousands of VMs just supporting that specific building block. So imagine when we move or migrate all these 60 building blocks into this private cloud, the number of VMs that we have to have. And we will have to scale the platform, not just upgrading to newer version of OpenStack, getting newer version of everything, right? The whole ecosystem will improve in general, a newer version of Python, a newer version of all the libraries, improvements in the code by itself, et cetera, right? Even the CentOS base. There is a lot of data planes. I'm focusing this presentation just in the control plane, but there is a lot of data plane that it's being sacrificed in this version of CentOS, which is the 6.7 with our network configuration. We have a bound configuration, the two physical interfaces, and because of this version of CentOS, it's a bug that was never fixed in this version of CentOS. We reduced the 10 gigabytes uplink bandwidth to less than 3 gigabytes. It's a big, huge thing. With CentOS 7.2 bumps it up to, I think, 7 or 8 gigabytes, which is really good, right? We don't run some kind of application that they require like super low latency or something like that. So far, none of the customers have actually reported any ticket about performance issue on that aspect. So this is why we're not focused on the data plane. Okay, so let's move into more of the tests that we did. So we actually took all the rally test cases and we published all the information so we could actually understand our cloud better. So you have the active state, you have the working one, that's the one that I described it, that we changed it. As you can see, the difference with the working, with the booting, sometimes actually the active, all of them are successful, but the working is not successful, right? Some things happening, especially you're using a specific SDN, like in our case, right? The SDN that you're using could have multiple issues. One that we identified, it has an API bottleneck on the number of workers that you can actually use. So you can increase the number of workers in the Neutron API, but the Neutron API is just a proxy to the SDN API, so the API at the SDN level has to actually handle all these API's workers. You know, it's just a bottleneck. It has to put in queue all these requests until it can successfully send it back. Then delete was also important. Why? Because of the Friday night, as explained, we have to kill all those VMs before creating the new ones, right? If the delete part takes forever, and sometimes we actually notice that there is some issues in that part, it's just gonna delay the whole patch window for more than 2 hours, and then we will start breaking our internal SLA with our customers, right? These are some of the tests that they already showed about the glance, and then we have the ones specifically for the networking time to list the networks and to show the networks. Something that we identify here with these failures is in Neutron, there is embedded the security groups, right? You have a default security group, which is embedded. And even that we don't use security groups in our framework, we actually open it up. The API is connected. So when you get show a network for a specific tenant, it doesn't only show you the network information and the ports, but also the security groups associated. And that's just a waste of a lot of time. We wanted to get rid of that. We actually decided to hack a little bit the system to get rid of that IPA. We couldn't. We broke more systems, so we had to put it back. And we know that in a newer version of OpenStack, we will be able to disable it 100%. We're actually moving all the security to an IP tables configuration, so we will not need any kind of security policies at all in our systems. Something interesting to say, so here at the very bottom, I'm just going to move to this side, we have the Nova API response time. So there is no rally test for that, right? Because that is something that you need to get either from your HA proxy configuration or for your Apache configuration for your logs, but there is no really rally test to doing that. So if you want to have that kind of information, you will have to extend your testing framework to collect the logs from the, again, from the Apache or from the HA proxy or whatever load balancer that you're using in your system. Now, we were deprecating some of the clusters. For some reason, we had to start moving clusters from one side to another in the data center. And we decided to go crazy in one of the tests to say, how can actually we break our cloud just adding more and more compute nodes? So this is a very interesting test. So we actually have a very stable system with 91 compute nodes. Then we added to 119, and then we added to 126. And something that we noticed that there is not really so much difference on the response time that we already have. So we can conclude that even that we couldn't add more compute nodes. And these are real compute nodes. This is not simulation data. This is not like magically hacking the system. This is really physical server added to a controller. And we couldn't add more than 126 in that test because we didn't have more available. Otherwise, we wanted to do it. But that's give us something, right? To 91 to 126, there is a significant jump. But that's not so much jump between the average response times that we have at 65, 67, not as much. This is 79, so sometimes there are some other parameters in the system that affects the testing, right? Maybe somebody runs some APIs, and somebody runs something that actually will affect your system. So in order to have accurate results, you have to run these multiple times and then get the average of these multiple tests. It's very expensive in terms of time. Having these tests keep running in hardware that is just being allocated for the test is, for us, wasting money, right? Because you had to pay for the space in the data center, the cooling power, et cetera, right? So we had to run the test really, really quickly, praying with the inf guys that they're not going to shut down those servers because they need to move it to something else, right? But actually, that was a very good experience. The same, as you can see, we went a little bit more crazy with the concurrency. We knew that actually will start failing 60, 80, but we wanted to know what would affect if this failure rate will increase with the number of compute nodes, and it doesn't, right? Again, we can conclude, jumping a little bit on recommendation, that from these size of compute nodes, there was not much, it's going to affect the performance of your cloud. So I'm running out of time, so I'm going to speed up a little bit. This is very similar test with other rally tests, but we actually conclude very, very similar that I already concluded, right, on the average time that we have in the last resource with different size of this configuration cluster. So another suggestion is the performance matrix that you can get. It could be very, very crazy, yeah, right? So these are some of the tests that we did in our performance testing, but you can see you can test way more things, right? All these combination and permutation. So let's test the Nova time, but increase the concurrency, but let's increase the number of compute nodes. So now let's increase the number of compute nodes and the API rate. The matrix is very complicated, and you're just going to spend a lot of resources and a lot of time, and maybe you're not going to get the results that you're really looking for. All that data will be useful, right? But maybe not for your use cases. So with these slides, I just wanted to highlight that the combinations for the number of tests that you can have with all the configuration that is around OpenStack could be very, very extensive. Now, I'm going to start jumping into the recommendation. As I said, your cloud is not my cloud. I miss an R, sir. But basically, what I'm trying to say is your use cases are not our use cases. The numbers that I published here, and you may see later when this presentation is published in the OpenStack website, it's not going to be useful for your private cloud, right, or for your public cloud, or for use cases. You have to run your own tests, right? We provide some of the tests that we did that we found that were useful for us, but not really for everybody. It's very important that you define your use cases and you extend your pipeline, your CI/CD with Rally as another gate of this testing, right? Very similar to what the OpenStack infra team does with all this tool and the different gates. So I would recommend to have a gate where you say, okay, this is my SLA for these things. If you change the configuration, you increase the number of workers for one thing and reduce it for another, or blah, blah, blah. You have rally tests that they keep running as a part of that pipeline, and you will find out if you're breaking something that you agree with your customer. I already talked about all the different permutations, so don't go crazy with them. Narrowing down your testing to your use cases. Rally is an amazing tool. It can be extended, keep adding more use cases. So you don't need to reinvent the wheel. You don't need to go to find your own testing framework. We're very, very happy with what we found with Rally. Obviously, there are some bugs, so things that they keep improving. So another thing is you can use a newer version Rally with older version OpenStack. Not has to be like 100% compatible. Because these APIs is very, very standard APIs. You don't test most of the extension of the APIs. Your hardware will play a very important role. specifically based on your architecture, right? If you identify that in use case you will be using Glens like us, maybe you consider to run your Glen server in a specific hardware dedicated for that one. Another set of recommendations, I talk about building your own performance scenario based on your own use cases. Contribute it back whenever it's possible to the Rally. If you build a plugin for Rally that you make an extended, please put it back into the community. That's going to be used for another teams. And then if you had scripts that we're using to run these tests, right, and a script to run concurrently thousands of VMs, blah, 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 you can actually publish those scripts in the ops code that is part of the repositories for the OpenStack. The working states explained before is different for the active because it's going to check metadata failures, routing a DHCP, security rules, and actually you can extend it to service functionality, right? For us, running a VM means a service, a web server, a Java service, something will be running, publishing information on a specific port, so you can actually write something for that. We're going to change our architecture. We're actually very close to release a new version of our internal private cloud with an extended set of functionalities. We're going to have HR proxy. We're going to have keep alive. We're going to keep using encryption. We're going to obviously improve. We're going to start using newer versions of everything. So we're going to rerun most of these tests and republish it maybe for Vancouver to compare with what we have in the past. We published a lot of our use cases in this white paper. It was published 2 or 3 weeks ago. So if you're interested in what we're doing at Workday, that is the link that you can actually use with a lot of information. And with that, sorry for running at the last minute. I would like to thank you. And if we have time for questions, I will take it. We can actually just talk a little bit offline. So I have a bunch of guys that I actually did all this hard work. So here in that line, so please wave a little bit. If you want to talk to them, they are actually the experts as well. So we can actually give you any kind of information. We are a very good team. So obviously you want to join us. We're most than welcome to hire people from this side. So thanks so much.